The European Space Agency is about to send a spacecraft to explore Jupiter and 3 of its moons. The Jupiter Icy Moons Explorer mission, nicknamed JUICE, was expected to lift off on Thursday, but a lightning risk postponed the launch, which has now been rescheduled for today. So joining me now is Olivier Vitas, who is the mission's project scientist. Thanks so much for being here with us. It must be incredibly exciting as you look forward to this launch. I mean, your agency said this is one of the most exciting missions that you've ever flown. So why is that? What makes this so exciting?
No, I agree with this statement. It's a fantastic mission. We are going to Jupiter and to explore the 3 icy moons, which are Europa, Ganymede, and a particular focus on Ganymede and Callisto. Our prime mission is Ganymede. And it's very exciting because we are going to check for habitable places inside the icy moons around a giant planet like Jupiter. And we're going to explore the liquid water ocean, in particular underneath Ganymede. So it's very exciting.
Yeah, before I ask you more about that, I just want to ask about the process. I mean, it's been touted by your organization as by far the most complex that you've done. So take us through what makes it so challenging. I mean, just getting there will be tough. It's a long and very unusual journey. So talk to us about that.
Yeah, there are very challenges associated with this mission. The first one is indeed the lifetime of the mission. We need to go there, and it takes 8 years, and then we have 4 years of mission. So it's a very long project, but it's not the most difficult aspect of the project. One of the most challenging challenges that we have to face with this mission is the harsh radiation environment at Jupiter, which is very difficult for electronic spacecraft instruments. So we had to build a spacecraft which can resist to the very harsh radiation environment. That's one thing, including large solar panels. We are far from the sun, so we need to power the spacecraft with 85 square meter solar panels that we need also to protect against the radiation environment. The other challenge is that we want to make precise measurement of electric and magnetic field around Jupiter and the icy moons. It's very important for our science objective to study the liquid water in particular. And for that, we need to have a very clean spacecraft from the electromagnetic point of view. We don't want to measure the disturbances from the spacecraft. We want to measure the electric field and magnetic field from the environment around the icy moons. And for that, we need to build a very clean spacecraft, and we manage. That's one of the most also challenges of the mission.
Yeah, and to try and find these the liquid water oceans under the surface. I mean, it's way down there. So what implications could this have? Is this about finding evidence of past life or sustaining life in the future?
Well, one of the big ideas of exploration of solar system and of the universe is: are we alone? Is there life somewhere else? And the first step is to find places that we call habitable, so that have all the ingredients necessary for life. And one of the main ingredients is the liquid water. So we need to find places in the solar system where we have liquid water. And it looks like the icy moons at Jupiter, but also around other giant planets, may be the best place to find liquid water. This is why we go there. So that will be the first step to characterize those liquid water, where there are all the oceans, how deep they are underneath the surface, how much water do we have, what is their composition. That will be the first step to understand this environment. And then if we find that this environment are interesting for life, then the next mission will be to search for life.
Oh, it's so fascinating. As you mentioned, it'll take about 8 years, to get there, but you don't get to just put up your feet on the desk and wait for it to get there. What will you be busy doing?
So when we arrive there in 2031, we will have 4 or 5 years of mission ahead of us with a very complicated trajectory. We have 2 orbit insertions, one around Jupiter and one around the Ganymede moon. That will be the first time that we will orbit a moon of another planet. We have 35 flybys of the icy moons during that mission. So Callisto, Europa, and Ganymede. So in terms of navigation, it will be quite complex, and there will be always a lot of opportunities to do science, sometimes at Jupiter, sometimes at the moon, sometimes in the system, Io, the dust. So we need to carefully plan all those observations. And to plan 4 or 5 years of observation, we need 4 or 5 years at least of work with the scientists to make sure that we have the best operation sequence. because we have to take care of the priority of the mission, the power available on board. We don't have a lot of power, only the power of a microwave oven to power the instrument and the spacecraft. We are far from the Earth, so we have a limited amount of data that we can get back on Earth. So we need to take that all into account to do the best science planning, and it will take 4 or 5 years.
Well, listen, we'll have to leave it there, but we wish you the best as you look forward to that launch later today. Certainly the world will be watching. Olivier Vitas from the JUICE Jupiter mission at the European Space Agency. Thank you so much.
Thank you very much.